Start recording.
Okay, hello everyone. Welcome to Code Club. So today we're going to be looking at the cats versus dogs exercise. Now, I'm sure you all have your own opinions on which, in fact, is the better pet, but that is not the question that we're going to be looking at today. Instead, we're going to be using machine learning to get our computer to identify if a picture is of a cat or a dog. Now, this is actually a little bit trickier than it might sound. So humans, we're quite good at this sort of classification. Even if you'd never seen a cat or a dog before, I would be able to show you a picture of a cat or a dog, and then from there you'd be pretty good at identifying if a photo was of a cat or a dog. Computers aren't really very good at that. Computers are good at doing exactly what we tell them. So they're really good at doing like calculations super fast. They're way better at humans than that, but they're not very good at kind of thinking for themselves. But what we can do is we can train the computer to recognize and classify these images. So what that means is if we give the computer loads of images of a dog and loads of images of a cat, then eventually the computer is going to recognize patterns in those images, and then from there it will be able to classify um, future images itself and recognize whether the image is of a cat or a dog. Okay, so let's get started. So I think Piers has just sent the link for the project in here. So what we need to do is we need to open this Google Colab Starter Notebook. Okay, so I'm going to open that up. I'll also send a link. I'll send a link to that there. Now what you need to do with this is you need to save a copy so that you're able to edit it. So we need to go to File, Save a Copy in Drive. Now to do this, we need a Google account, okay? So does everyone have a Google account? I guess could you, if you let us know in the chat if you don't, and we'll work this out. Otherwise, if everyone does have an account, then we should be able to carry on. Okay. It looks like we should be okay. So like I said, if we go to File, Save a Copy in Drive, then that's going to give us a copy of this document so that we're able to edit it. Okay. I'll just give everyone a sec to make sure that they've got this. Okay, so we can see this document that we have here already has quite a lot of code that's written for us. So we don't need to completely start from scratch, but so we're going to be filling in these last little code blocks here at the bottom, and we're going to be using the code blocks that are already given to us here. So the first thing we need to do is we need to say what the size of the images we're going to be using. So like I said before, the way we're going to train the computer to recognize the images is to show it loads of images of a cat and loads of images of a dog. And these images that are provided in this data set of images are 160 pixels wide and 160 pixels tall. So that's going to be our image size that we're going to be using to train. So we're going to create a variable. I'm going to call that image underscore size. Now you'll notice that I've used capital letters for this variable. So this isn't strictly necessary. We don't need to do this. It could be lowercase. But what But okay, I'll slow down a sec 'cause it sounds like some people are just getting to here. Um, so so this the name of this variable, I've used capital letters here. This is kind of this is what we use in programming to show that this variable will not be reassigned. So we're going to this is a constant variable. We're not going to assign it again. So so we use capital letters to show where we're not going to give it a new definition later on. So I'm going to set the image size equals to, in brackets, image size. Now the reason I'm using image size is because if we look in the code that we've been given before, we already have a variable called image size that's 160. So we could type 160, or I think I'm going to use the variable that we already have here. So I'm using image size, and then image size again. So this is for the height and the width. And then I'm going to say comma 3. Now the 3 is because of the color. So that's each of the values for red, green, and blue, which can make up any color. Okay, so we have our image size set. So this is telling the program that we've got the images for our training are going to be 160 by 160, and they're going to have 3 layers of color each. The next thing we're going to do is we're going to import the training model. Okay.
Ben,
Yes.
could you show, I think we had some late starters, how to save a copy in their drive. Could you demonstrate that again, please?
Okay, so if you go to the link that we've provided, you'll be taken to this page here. What you need to do is you need to press File, Save a Copy in Drive, and then that's going to open up a new tab, like I've got here, called Copy of Retrain Existing Model Starter. And that's going to be where we're going to work. Okay. Right. So next we're going to be importing the training model that is provided by the machine learning library that we're using. So what I'm going to do is I'm going to create another variable. I'm going to call that original model. And I'm going to set that equal to tf dot keras dot applications dot mobile, and that's got a capital M, net with a capital N, v2, that's a capital V, and then I'm going to open up brackets. I'm going to type input underscore shape equals, and then I'm going to use the image shape. Now, I've just realized I have made a mistake here. What I've done is I've called that image size, so that should actually be image shape, I think, because we've already got image size up here, so this should be image shape. Okay, so this is going to import the existing model that is provided by the TensorFlow machine learning library that we're using. So just to explain, this is the MobileNet v2 training model. So this is a training model that is provided by the library, and it's designed to run on, I think it says, on a mobile device with limited battery, such as a phone. So it's not the best library for classifying images, but it's designed to run on lower powered devices. Okay, so we've got that imported. So let's see how good this library is that we've imported is at recognizing a picture of a dog. So what we're going to do, so we've imported the model, and then we're going to use a function that already exists. So we have predict with old model. So we're going to use this function here. So I'm going to call predict underscore with underscore old underscore model. And then in here, I need to pass in the URL for the image of a dog that we're going to recognize. So we'll just take a look at the image that we're going to use. So I'm going to go to it's dojo.soy / predict -dog. Okay. So if we go to that link, then we'll see the picture of the dog that we're going to be asking our model to classify. Okay. So we've seen the picture there. So we can now type that URL into this function. So we're going to have predict with old model, open the brackets, and then within the quotes, we're going to have that same link. So I'm going to put https / dojo.soy / predict -dog. Okay, so that's going to take that image that we've linked to there. It's going to download it, and then it's going to predict what it is using this model that we've imported here. Okay. So I'll just wait a second for everyone to get to this point. Okay. So what we can do now to run our program is we press run time at the top, and then we're going to press run all. Okay, so that's going to run through each block in turn. So this might take a second because it needs to download all the training data in order to train our model, and that takes a second. And then after that, it will run our prediction. Okay, so it's running our prediction. So it's downloaded the image. Okay, so we've got our prediction here. So we can see the image that we've asked it to predict, and what has it predicted. So it kind of gives us what it's classified it as with its percentage of certainty, how certain it is. So let's have a look what we've got. So our model, so the top result is a matchstick, and it's 49.7% sure that this is a photo of a matchstick. So that doesn't sound quite right. That's not very good. What else have we got? Pinwheel, plunger, syringe. This isn't working very well at the moment. I can see two dogs, so we've got a Chihuahua in there and a German Shepherd, but it's not very sure that it's either of those. So it's not at the moment working very well at identifying our dog. In fact, it's pretty bad. So what we're going to have to do is we're going to have to adjust our model so that it's better at classifying cats and dogs, because that's what we want it to do. So don't worry, we're gonna make our predictions a lot better than we've got so far. So what we can do is we can remove this line here, predict with old model. Let's just delete that. We don't need that anymore. It's obvious that that the original model isn't very good at classifying cats and dogs. So what we're going to do is we're going to remove the top layer of the model that we've imported. I think the document has a good, if I just go to the right page, this has a good diagram somewhere.
It's page 1, not 3.
Ah.
So yeah, next one.
Yeah. Okay, so this has a good diagram of how our model works. So you can see there's several layers to our classification, and these earlier layers, they're not matching exactly what the photo is. For example, the matchstick, pinwheel, etc. That's only the top layer that is matching what it thinks it is. These earlier layers are just matching patterns within the image. So for example, it might see a line at a certain angle, and using that, it would be able to pick out that feature of the image. It's only when we get to the very top layer that we're classifying exactly what we think the image is. So what we want to do is we want to remove this top layer, because this top layer isn't very useful for what we're doing. It's not classifying the images to what we want. So what we can do is, where we've got this line, original model, we can edit this. So after where we've said what the image shape is, we can put a comma, and we can say include top. So that's include underscore top equals false. So that's just saying we want to import this model, but we don't want the very top layer, which is the one that's classifying our image into these categories that we're not really interested in. Okay, so we've got our model without the top layer. The other thing we want to do is we want to set our model as untrainable, because we don't want to change anything else. So we're going to say original underscore model dot trainable equal to false. Okay, so we've got our model. We're saying we don't want the top layer, and we don't want it to be trainable. Okay. Right. So next thing we can do is we can train the model that we've got with some data. Okay, so as I said before, we can train our model by giving it loads of photos of cats and loads of photos of dogs. And if we tell our model that that all these photos are of cats and all these photos are of dogs, it will start to recognize the patterns between them, and it will become better at recognizing them. So this page has a little bit of a description here about explaining why we need varied data. So it gives the example of, if we give our model training data where all the cats are black, but we don't give any pictures of black dogs, then the model might start to learn that any picture of a black animal is a cat, and that's not true. So we need to make sure that we have a lot of varied data in our training data. So luckily, the TensorFlow library has provided lots of great pictures of cats and dogs that are really varied and really good for training our model. Okay, so what we can do is we can import our training data, which I think is already here somewhere. I believe, yes, so here. So we have our import TensorFlow datasets. So this is a dataset called cats and dogs. And from that dataset, we're going to split that up. So you can see we've got this split and it says train, which is the first 80%. And then we've got train between 80 and 90% and train 90% onwards. And those three map to these three variables here. So we're going to use the first 80% of the training data for training. We're going to use the next 10% of the data we're going to use for validation. So that is used while the model is training itself. And then the final 10% of the data we're going to use for testing our model. So that's so that when our model is training itself, it's able to give us an accuracy reading. So it's able to predict how accurate, how good it is at classifying these images. So that's why we need to split our data set up. It's also important, so we might wonder why we can't just test our model with the same data that we're training it with. So the reason is we don't want our model just to recognize specific photos of cats and dogs. We want to be able the model to recognize any photo of a cat and dog. Okay, so we've got this training data already imported here. And we can start to use that to train our model in recognizing these cats and dogs. Okay. So what we're going to do is we're going to split our data up into batches. So these groups of the images. So I think these batches are used for how many of the training data images are used before the model updates itself to become better at recognizing. So this is a value that can be tuned. So it's possible that adjusting this value will affect how good our model is at recognizing these images. So to start with, we're just going to use a batch size of equal to 32. So we're going to create a variable called batch underscore size. Again, I'm going to put that in capital letters, and I'm going to set that equal to 32. So 32 is a good place to start. Maybe after this session, you might have a play around and see what effect adjusting this value has. But for now, we're just going to stick with that. The next thing we're going to do is we're going to create another variable, and this one is the shuffle buffer size. So I'm going to create a variable called shuffle underscore buffer underscore size in all caps again. I'm going to set that equal to 1000. So this is another variable that we could maybe adjust. So this is used for randomly shuffling our images when we're training them. Okay, but we won't worry too much about that. We'll just set that as 1000 to start with. Okay, so now we've done that, we're going to create our batches. So first of all, we're going to create our training batches. So I'm going to create a variable called training underscore batches. And I'm going to set that equal to training underscore data. So that's the data that that was already given us here. So I'm going to set that equal to training data. I'm going to say dot shuffle, and then I'm going to pass in the shuffle buffer size. And then after that, I'm going to say dot batch. I'm going to pass in the batch size. Okay. So now I've got that. I need to do the same again for both the validation batches and the testing batches as well. Okay. So I'm going to write validation batches. I'm going to set that equal to the validation data. And same again, I'm going to go dot shuffle. I'm going to pass in the shuffle buffer size. I'm going to say dot batch. I'm going to pass in the batch size. And finally, I need to do the same again for the testing batches. I'm going to set that equal to testing data dot shuffle. Again, I'm going to put the shuffle buffer size dot batch size. Feel free to use copy and paste, and just to change these two values. You don't need to type them all out manually like I did, but it just needs to look the same as that.
So do you think at the end of all this, it's going to work?
Who knows? Okay. So hopefully everyone's got to that point. So the next thing we're going to do is, now we've created our batches of data that we're going to be using for training our model. Now we need to create the new layers that we're going to add on to the top of our model that allows it to classify cats and dogs. Okay. So the first one we're going to add is we're going to create a variable called global average layer. I'm going to set that equal to tf dot keras dot layers dot global average pooling 2D, and then open and close brackets at the end of that. Okay. Then we need to add another layer again. We're going to call this one prediction layer. So I'm going to create a variable called prediction underscore layer. I'm going to set that one equal to tf dot keras dot layers dot dense. I'm going to have open and close brackets at the end of that, but in the brackets I'm going to put the number 2. Okay, and this is because this is the very top layer, So this is showing that, that this layer needs to decide between two classes, so cats and dogs. So this is the very top layer and needs to come to a final decision. Is it a cat or is it a dog? Okay. So once we've got our two layers here, we need to assemble our final model. So what is our model going to be made up of? So our model, we've got, we're going to use the original model without the very top layer. We're going to take that, and then we're going to layer our two extra layers on top of that. So we're going to have the original model plus this global average layer plus our prediction layer, and together that is going to make our model. Okay. So to assemble that, I'm going to create a variable called model, and I'm going to set that equal to tf dot keras dot sequential. So that's with a capital S. So that shows that that these layers are going to be performed in sequence. And then I'm going to have open bracket and then open square bracket, because this is going to be an array we're passing. So we're passing all the layers in. So the first one we want is the original model that we imported from the library. The next layer we want is our global average layer, and comma, and then the final layer we want is our prediction layer. Okay, so that has assembled our model. The next thing we need to do is we need to compile our model. So this turns it into something that we can use to train and make predictions with. Okay, so we've got a couple. Was it just one more? Yeah, we've got one more variable that we need to assign here before. So this is our base learning rate. So I'm going to create a variable called base underscore learning underscore rate. And I'm going to set that to 0.0001. Okay. So this is telling our model how quickly it should learn. So this is kind of a trade-off. So if we learn too slowly, it's going to take ages to learn, and it's going to learn really slowly, and it would learn. However, on the other side, if we set our learning rate too high, it's going to try and come up with kind of reasons for classification far too quickly, and it might miss things. So it's kind of a trade-off one way or the other. So this is a value that we can adjust later on and see how it affects our model. So now we've got that set. I'm going to compile our model. So we do this by saying model dot compile. Then we need to open the brackets, and we need to set to write optimizer equals tf dot keras dot optimizers dot rms prop. Then we want to open another set of brackets, we want to say that the learning rate, so it's learning underscore rate equals, we're going to set that equal to the base learning rate. Okay. And then we want to go outside that bracket, so between the two brackets that we've got, because we need to put some more inside here. So we're putting a comma. Then we're going to write loss equals TF dot keris dot losses dot sparse categorical cross entropy. So this is our loss function that we're going to use. So the guide gives a bit more information about what this is. So it's so it tells us that it's used for the model to check its performance during training. We won't worry too much about that, but we'll just set the that as our loss function. And then finally, after that, after the open and close brackets there, we need to type metrics equals, and then we need to create an array. And within that array, we have a string in quotes, single quotes, accuracy. So I think what this does is when it's compiling our model, it's printing out the accuracy so we can tell how accurate it is while the model is training. Okay, so I'll just give everyone a sec to make sure they've got that, because there was quite a lot to type there. Okay, so after this line, we're going to type model dot summary and then open and close brackets, and that's just going to give us an output to show us the summary of our compiled model. Okay, so once we've got that, let's have a look at the our model. So we can go to runtime, run all, and there we go. We've got an output of the model that we've just compiled. Okay. Right. So the next thing we need to do, we've got our model compiled. Now we need to train it on our cats and dogs data that we've provided. So we need to create another variable for this, and this is the number of epochs we'll train for. So what an epoch is, this is a complete run through of all the training data that we've got. So normally what we'd do is we'd run through all the training data several times. However, every time we run through the training data, it's going to take time. So the higher the number of the epochs, the longer the model is going to take to train. With that being said, the more times we run through the training data, the more accurate our model is going to be at predicting. So again, this is a trade-off between the time it takes to train our model and how accurate it is. So I'm going to create a variable called training epochs. I'm going to set that equal to 2. I think in the guide it suggests a value of 10. So you might want to go afterwards and change this to 10, and it will make your model more accurate. But I think with 10 epochs, it will take probably about 10 minutes to train all the data. So just to keep us going on time, we're just going to use 2 epochs, even though our model won't be as accurate using that. Okay, so now we've created a variable for our number of training epochs. Let's train our model. So to train our model, we're going to use our computer's GPU. So that's the graphics processing unit of our computer, instead of the CPU, which is the central processing unit. So the CPU is the normal, that's the general purpose processor that our computer uses, and the GPU is the processor that's used mostly for rendering images and doing graphical calculations on our computer. But it turns out for this sort of machine learning, the GPU is much more efficient than the CPU. So we're going to use the GPU of our computer to train our model. So to do that, we're going to type with tf dot device, and then we've got open brackets, and then in quotes we're going to type / device colon GPU colon 0. So this is going to tell TensorFlow to use our GPU, and then I'm going to put a colon at the end of this line, and then I'm going to write history equals model dot fit, and then open brackets. I'm going to say training batches. So this is going to be the training batches it's going to use, comma, epochs. So this is where we're going to pass our training epochs variable that we just assigned, comma, validation data equals validation underscore batches. Okay, so that's saying instructing our model to train with the training batches for 2 epochs, because we're using this variable. So we're going to say train for 2 epochs and use the validation batches to use for validation while the model is training. Okay. So when we've got that written, we're going to press runtime, run all. So this is going to take a few minutes to train. So as I said before, the number of epochs we specify instructs the how many times to go through the training data. So we've given 2 epochs, which means it's going to go through all the training data twice. So you can see its progress through the first epoch at the moment. And you can see on the right here the accuracy of the model as it's training. So you can see the accuracy going up. So the more data, the more example images, the more training data that our model sees, the higher its accuracy gets. Okay. It looks like we're just finishing up the first epoch. Okay. And now we're going to go through the training data again. Now, as I said before, 2 epochs isn't very many. It would be much better with, I think the guide suggests 10, but you could go even more than that. But obviously, the more epochs we give, the longer it's going to take. So maybe that's something you want to look at afterwards. After this session, you could try and train your model for more epochs and see if you can get a higher accuracy using that.
I think someone's commented that you have a faster GPU, but I believe we are all running on Google's hardware, so it should be about the same. There are options to connect to your local hardware if you have invested thousands in high-end hardware. But for this stuff, I think we're all using Google's hardware for compatibility. And there's one person who's got an issue. You'll need to share a link. Ben, can you quickly show how to share a link? And I can try and work out what's wrong, or you could take a look at it.
Is that using this?
Yeah, and then you need to do change anyone with the link, and then you can copy link, and that'll at least get us the ability to look at the code and point out what's wrong.
Great. Okay, so it looks like our model has finished training. It looks like it's come up. It reckons it has an accuracy of about 0.62, so that's about 62%. So hopefully that will be enough to correctly identify our image of a dog. So let's have a go. So remember that image that we tried at the beginning. So originally our model thought this was a matchstick, which obviously wasn't right. So now let's see what it will say. So since we dropped the top layer, so it definitely won't tell us it's a matchstick anymore, because our model has no idea what a matchstick is anymore. It's either going to tell us it's a cat or a dog. So we're going to hope that our model can identify that this is a dog. Okay. So in this final cell here, we're going to type predict underscore image. And then in brackets, we're going to put in this same URL that we used before. So remember, that was https://dojo.soy/predict dog. Okay. So we don't want to go through all our training again. So we're not going to press runtime run all this time, because we don't want to wait for this to train again. So I'm just going to press the little play button that's next to this cell. So that's just going to download the image of our dog. And unfortunately, it has predicted that this image is a cat. So I went through this earlier and I had to go. And before, when I did it, I used 10 training epochs, and it did correctly identify that this was a dog. But it appears that with only 2 epochs, that might not be enough.
Give a go retraining. When I did 10, it also told me it was a cat. And when I've just run this with 2 epochs, it did tell me it was a dog.
Okay. So we'll have a go at the training again. So okay, we've got, so it reckons about 62.3%. Let's see. See if we get any higher.
And you had a lower accuracy than mine, which told me it was a dog. So it's obviously for that particular picture, mine was correct. But overall, my one came up worse.
Okay, let's see what we get.
Yeah.
So so the more training epochs we give it, the better the accuracy. I suspect for a low number of epochs, would it be because of the shuffling, it's going to be, I guess, slightly random between
yeah, they'll differ more and more.
Yeah.
In the first step, our values are quite different, and then in the second step, they're a lot closer for the second epoch. So someone has shared theirs. Did you have a problem with yours, or have you finished? I'm not sure if I'm supposed to read out names at all. So Okay, so that one says they're finished. And oh, Ben, can you get the one from 349 and click it and take a look while yours finishes training? Or maybe when yours has finished, as it's due in about a second.
Yes.
Oh, this is confusing.
Unfortunately, I'm getting access denied. I think you need to, when you share it, you need to say anyone with the link can access. At the moment, it's saying that I can't access, unfortunately.
So let's see, have you done better?
Okay, so we've got ever so slightly better accuracy. So we're going to predict the same image with our new one, and we've got cat again. Okay. So once we've got our model, we probably need slightly more epochs. This is probably not enough. What we can do is we could find pictures of a dog on the internet. We can just go to Google Images. So let's say this dog here. So we can get any picture of a dog. If we right click on the image from Google Images, we can press copy image address, and we can test our model on this different image here. So I can remove this link to this dog and paste this lovely Labrador Retriever. Is it lovely? Okay, and let's test this, and it's identified that as a cat as well. So maybe should we try a cat? See if it says that's a dog. Which of these cats look good? Okay, we'll go with this cat. Let's try that. Can it correctly identify that? Lovely. That says that's a dog. Okay, so so our model appears to be very good at telling us exactly the opposite of what the animal is. So yes, potentially we need some more training epochs.
I think clearly we just need to inverse it.
Yes. From our testing so far, that would appears to be the solution. Okay. So as I said when we were going through this, there are some of the other things that we can change as well, such as the learning rate and the batch size. And adjusting these values would adjust the accuracy that our model is able to get to. But yeah, I think that's all. We'll just we'll stick around for a few minutes just in case anyone has any questions. So someone said they went through 3 epochs and it correctly identified the dog. So yes, so more than 2 it appears is required. The guide does recommend 10. That will take I think about 10 minutes to go through. So it might be worth just doing that and waiting for that to train. Okay, thank you very much, everyone. It's been great fun going through this with you, even if we haven't got our model correctly identifying cats and dogs at the end. I think we've learned a lot going through this. Cool. Thank you very much for joining today, and wish you the best of luck for your return to school soon. Thank you, everyone.